All-Star CNC. Appreciate everybody joining us here at our vacuum clamping parts holding webinar. Today is November 9th, 2023. So again, thanks for taking your time out of your busy day to join us on this webinar. We are going to work hard and have worked hard for this to be an enlightening, informative, and worthwhile experience for everybody here. So today I'm joined with a few of my esteemed colleagues. With us today is going to be Margot Murphy, Daniel Sandeman, and Mike Murphy, otherwise known as Coach Mike. So before we begin, just a few housekeeping topics and instructions here. So for all of our attendees, in the top right of the interface there's a few features that you're going to be using and even interacting with. First of all, top right, you're going to see the chat area. This is an area where you're going to be able to chat both publicly and also internally here with our staff at All-Star. So if you have any questions, concerns, technical issues, or otherwise, we will do our best to fix that as quickly as possible. Next, you're going to see the Q&A section there up in the upper right again. And we encourage this. We want to, this is a place where you're going to be able to ask questions throughout the webinar. Ask as many questions as you like. We certainly encourage it. And we're going to have a Q&A session at the end of this webinar. We're going to address hopefully all of the questions, but if there's any, in any event, if we can't get to your question, we'll be sure to reach out to you personally and answer that for you. Next in line, we have polls, and this is an interactive aspect to the webinar today. So we're going to be asking you a series. We're going to ask you a series of questions. We appreciate your input through the genesis of All-Star. We have improved and grown and evolved through your personal input on your industry, your applications, and your products that you need, et cetera. So please do use the polls. And then lastly, you're going to see an area there for handouts. So throughout the presentation here, as we go through the various topics and products, you're going to have an opportunity to download more information as we go through that. So just as a quick introduction, a little bit about All-Star. We've been in business for more than a couple of decades. Our company created vacuum improvement products for the CNC industry ever since our inception. It was the root of our company. And over the last couple of decades, as we've grown, not only are we serving clients in our through the U.S., but all around the world, and we have well over 4,000 customers and companies that we service. And during this time, even though that we're working on gasket material, there's machinery, equipment, testing, manufacturing processes that are needed to make high quality products, and we have invested accordingly, and we'll do so. We also partner with a number of CNC manufacturers that are out there, which we'll get into here in a moment, and we support virtually every CNC manufacturer on the market. So gasketing, parts holding, CNC vacuum tables, it's all that we do here at All-Star CNC. It is our core competency. We do nothing else other than help increase parts holding strength for all of our clients. And we've been pioneering techniques known as vacuum clamping or true vacuum clamping under parts. And we've been producing products to support these methods. And frankly, we've proudly become the go-to resource in the industry for vacuum parts holding, and we take pride in that moniker. What's more is that what we also take pride in is our customer service and our consultative approach. Well, that was our web chat, so somebody was going to pick that up, and that's part of our customer service. We try to pick up customers' inquiries anytime, all the time, even in the middle of the night and off hours. So that was one of our web chats that just came through. Anybody else is welcome to use that as needed too. It's just one of the many resources that we have here at All Star CNC. So what I was mentioning is that we are very consultative. We sit on the phone for a long period of time and try to teach our clients, support them, and discuss their projects and their individual needs. So feel free to reach out to us at any time. So here are just a few logos in our industry I think that most of us will recognize. And these are some of our OEM partners. And all of these companies here, you're going to be able to either purchase All-Star CNC products directly. Our products are embedded into the machines, and then when they're delivered to the customer, to you. Or a new venture this year has been vacuum clamping kits, parts clamping kits that you'll find through a number of these CNC OEM manufacturers. And these are turnkey kits, everything that's needed, which many of the products you're going to see here in the presentation today. So before I hand over the helm here to Mike Murphy, just a quick introduction. He is known as the head coach at All Star CNC, and I think he has that for good reason. There is rumors that Mike was conceived on a vacuum table. Don't know for sure, just a rumor. But back in '96, through the origins of the company, back through some adhesives work, customers were coming to Mike and his father for better weather stripping. And that was really the genesis of the company. With weather stripping came sealing. With sealing became gaskets. And then after attending their first wood. Okay, well, we need to turn that off. Apologies for that. That's been fixed. So after the first woodworking show, Mike and his dad saw a vacuum hold down with CNC machines and had this epiphany. They had this brainstorm that, wow, we could really do better here using certain techniques, certain physics, which we're going to talk about, really around vacuum clamping and the science behind that. So since 1998 and all the way up to 2022, our company has grown and we've evolved and again, become that go-to resource in the industry. We are a true believer in American manufacturing and a true believer in science. And so for everybody who's attending today, we just want to let you know that we appreciate your time, and we'll be offering a special promotion for our attendees that stick with us to the end of the presentation, and also a giveaway. So hang out to the end, and we appreciate your attendance. So we're going to start off our presentation here with a little poll. We want to get to know you, our attendees, as best as we can. And my colleague Margot here is going to present you with our first poll. So as you see,
guys, just as Alex mentioned, that we help people all around the country and the world hold their parts on CNC vacuum tables. Today, you guys could click over to the poll and we can see what industry you guys work in. We help everyone from cabinet manufacturers, furniture, signs, arts and crafts, musical instruments, sporting equipment, and so much more. So just get an idea of who we have here today. It would be great if you just head on over there. We got some answers going on here. Oh gosh, a lot of others. Interesting. Okay, I'm going to close up this poll, and it looks like we got quite a few cabinet makers and furniture makers here. And we're going to go over to Coach Mike Murphy, and he's going to get this presentation started. Thank you for doing the poll.
Thanks, Margot. Once Margot closes that poll, you're going to be able to see the results of that poll in her top right under the closed area. And without further ado, we're going to go ahead and pass over the helm here to Mike. Mike, welcome, and it's all yours.
Great. Alex, thank you very much. Appreciate all of the hard work you put into our webinar here today. We're looking forward to using our new webinar tool, our new toy, and we appreciate everyone coming along. Brought Alex on over the last couple of years, and really appreciate all the work he's put into it. They always say hire someone smarter than you, and luckily for me, that large group of people qualify for that position. So Alex, thank you very much. And thank you guys for joining here today. I was looking at the list of attendees that we had today. I see a lot of longtime customers, a lot of our partners and OEM distributors, as well as some new customers that are interacting here with us for the first time. So looking forward to all that. And we certainly look forward to possibly passing on some education to you guys. So I'm going to go through some slides here today, give you some basic ideas of the concepts that we try to produce to our customers, provide to those. I've always said over the years that half of what we do is supply gasket solutions, and the other half of what we do is supply ideas, knowledge, techniques and concepts that maybe aren't available elsewhere. So it's a little bit of education, a little bit of a product providing, but we certainly appreciate you taking the time to look at some of these slides. So I'll get right into it. These are my cavemen friends. I bring these guys with me on all my presentations around the country because I think it is a very apropos image on about what we're going to discuss here over the next hour or so. Gentleman here on the right, caveman style. I always joke around that maybe pulling parts right through an MDF spoilboard is a caveman style. That's how they used to do it back in the old days. But the gentleman here on the left, maybe some gray hair, has a little bit more knowledge. Maybe he's gained a few things, and he's got some different ways to do things, maybe better. And if we take that approach, let's take some time to realize there's other ways to do things that maybe we can start to hold parts better, more parts in less time. And that's what we're trying to get our customers to achieve. So we can get right into it after we say goodbye to our cavemen friends. So at the heart of what we're doing is, what is vacuum? And I think too many customers that we deal with come to us with the preconceived knowledge that vacuum is somewhat like you see on the screen here. Turn on a vacuum cleaner and sucking parts up, or in the case of a router, sucking parts down. And to me, I don't think that's the right mindset that we have. We don't want to use a vacuum cleaner to hold parts. What I think we should be thinking about in vacuum is a little bit more what the true meaning of vacuum is, which is from the Latin term vacus, meaning void of air, void of matter, what outer space has to offer. And that's a true vacuum. And if we can use vacuum, we start to create air pressure differential. And what we need to do is enclose a space, right? If we want to have vacuum, we need to define that space that we're going to have the vacuum in. And gasket defines that space. So when we create that air pressure differential and less pressure under the part in that defined space versus the atmosphere above, air pressure differential. So it's a big difference between downdrafting, where you're actually almost like asking a wind to hold a part in place. Vacuum clamping that we're going to get into here is a different science. We're not just improving things, we're changing it. So we want customers to get their minds around the vacuum concept. Because vacuum pressure is anti-vacuum. If there's a void of pressure, the pressure is going to go up against it. That's what science says. And in the router world, probably looks a little bit more like this, right? We want that pressure of the atmosphere to come down on the part, hold that part in place, so that the more parts you cut, they're staying still and cutting them fast. So air pressure differential also on this planet being used in other manners. Anyone that's ever flown in a plane is taking advantage of air pressure differential. The air pressure above the wing is less than the pressure beneath the wing, and that's what caused that plane to lift in the air. So if we can get a 747 to 30,000 feet, maybe we can use that same pressure differential to get a drawer front to stay down on your router. So when we get into this idea, we know that all of our customers that we deal with over the last couple of decades are unique. There are so many variables that each shop is going to come to us with. There's a list of them here. We can go through types of routers, the strength of the vacuum system that they're using, the size of the parts. Are they cutting plastic? Are they cutting wood, up spiral versus down spiral tooling, elevation levels? There's just a laundry list of variables that factor into each shop and how they manage cutting their parts. So we know that there is no one size fits all, because there's always a variable that's going to change from shop to shop. And knowing that each shop is a little bit different, there is going to be no easy answer. So we'll go through a whole bunch of different options here based on maybe what is going to be the best fit for you. So ultimately, the test is, can I hold my part? Yes or no, right? When customers can hold their parts successfully, they usually don't call us, right? We don't get calls from people saying, hey, my vacuum's working great. What are you guys up to? Our phone rings when customers can't hold parts and they need to get better vacuum performance. And why can they not hold their part? Well, there's usually a couple of variables playing in there. As part size gets smaller, as most of you probably experienced, part size gets smaller, it becomes difficult to cut. Vacuum pressure loss is the other variable that we need to account for. And as vacuum pressure loss increases, at some point, there's the place where you can't hold your part, whatever part that is, whatever vacuum pressure loss it is. So that is the area that we need to concentrate on. And the fact that we can't change the size of the part, that means we got to change the only other variable that is available to us, which is vacuum pressure loss. So gasket solutions that we're going to get into here, the main concept is to prevent the loss of vacuum pressure, prevent the leak of vacuum pressure, because leak is the enemy. Your vacuum pump is capable of great things. It's not always the size of the pump, it's how you use it. So it's capable of great holding power as long as we eliminate the leak that is inherent in the system. So we can get into that a little bit here. First off, very first question that we ask those customers who call us, like I say, they're usually the folks that are having trouble holding their parts. So when that phone rings, the first question we ask, what type of router do you have at your shop there? And when was the last time you changed the grid gasket in that machine? Because I think we have to start here. A lot of folks are interested in their parts for good reason, but we have to start at the base, what we call the foundation of the house. So we always talk about the grid gasket, what kind of machine do you have, and do you have that thing set up properly? So in order to do that, we're going to send you guys a quick poll here. First poll question of the day, or second quick poll question of the day. When was the last time you changed your grid gasket? A couple of different options up here if you guys want to submit some questions. We always want to know kind of what machine we're dealing with, gets us an idea of what kind of vacuum strength it has. And we want to make sure that customers are getting the concept of a fresh seal in that table. When customers haven't replaced their seal in a couple of years, or maybe since they bought the machine, sometimes a fresh seal under that spoil board is all the improvement that they need sometimes to cut those parts. So let's get some of those answers coming in. You guys can take a look at those.
Just as a quick reminder to everybody, when you're looking at the top right there, if you look at the polls and what's open, you're going to be able to see how it's polling currently. And once it's closed, we'll get those results. But appreciate everybody's input. Thank you.
Good thing Mike's going to talk about grid gasket here, because we've got about 14 people there to say, what is grid gasket? You're about to find out. And it's about 24 people that answered what we would say maybe correctly, every 500 working hours or every time you change your spoil board. So some fun answers here. Quite a few of you haven't since you purchased your machine. So most likely you'll be ordering some grid gasket after this presentation. So I'm going to go ahead and close this up. You guys are welcome to view it over there. We got 72 responses. That's great. And Mike's going to tell you a little bit about grid gasket.
Margot, thank you very much. So grid gasket is kind of what we say kind of the start of things. This is step one to prevent vacuum pressure leak between the router grid and the spoil board or fixture board is crucial to get proper vacuum performance at the part. So not sure if this kind of photo looks familiar to anybody. Photo on the left here is the router table and a spoil board. And you can see that slight gap that exists between there, whether it be a warped spoil board or some irregularities. Maybe there's an irregularity on the table. But if there's a gap that exists there, vacuum vacuum pressure is somewhat like water. It's going to travel the path of least resistance. The easiest way out is where it's going to head. So vacuum pressure can certainly escape from a gap like this. Picture on the right, a little bit more sealed, and we've done that with the gaskets material in there in this regard. Oops, let me, there we go. New toy. So that gasket in that table there, as you can see, sticking proud above the channel by about 1/16 of an inch in this case. And when that vacuum engages and that gasket sucks down, brings that spoil board flush up against the table, eliminates those leaks, eliminates the gaps where that vacuum pressure is going to get away from you. We want to make sure that that table is sealed all the way around. And we do this a few different manners. The grid gasket is intended for all of our customers. Anyone that's using a router with a grid table, I believe, should use grid gasket in there. Anyone that says their machine doesn't need grid gasket, I would have a respectful disagreement with that. I think gasket seal is a great solution to get that lip of the freezer door mentality. We always talk about if your ice cream at home doesn't stay cold, don't question your freezer. Let's check the lip of that freezer door first. Make sure that cold air stays in there. And for a router, let's make sure that vacuum pressure stays in there. And we have to maintain it in all the manners that we can. And especially tables with multiple zones here. The image that you see on the table here, 4 different zones on this large machine. Each of those zones will have to be individually gasketed for, so that when we turn on zone A and turn off zone B, that gasket seals each of those zones as we bounce from zone to zone. The grid gasket rules of thumb that we've passed along over the years. One size does not fit all. As I say, there's a lot of different machines out there milling their channels at different sizes, different widths, different depths. So we have to assume that there is no one size fits all. Channel size dictates gasket size. Let us know what that channel size is, width and depth. We always recommend a non-adhesive material in there so that when you do replace that material, we're not leaving any kind of adhesive residue behind. We don't want to gum up those channels, start to collect dust and grime. And as Margot mentioned earlier, about every 500 hours or so of machine time is what we usually recommend. If you change the oil in your car every 3,000 miles, let's use the 500-hour mark as a good time to replace that seal. It is much like a filter in your house. Get a good seal to get maximum performance out of that vacuum system. And vacuum is really the only tool that is often used to hold parts. We're not using vacuum and clamping, vacuum and gluing. If you're using vacuum, as we say, let's max the vac, and this is where it starts. Other rules of thumb that we like to talk about is round pegs don't necessarily fit into square holes. So why we put round gasket into square channels is a mystery to us. We always think that square gaskets are a much better fit. You can see these round cords, very often oversized, which is good. You want it to be taller than the channel, but round cord is often wider than the channel as well. And as a human, getting a wider gasket into that channel, you've got to stretch it, you got to mash it in there, and that leads to some irregularities. And you can see that right here in this photo, where what we like to do is provide our square gasket. We cut it with our equipment here, cut it to the width and depth that is required for your machine, so we get a proper fit in there, consistent, less leak. That's the number one thing. And so we ask customers to measure both the width and depth of those channels. And as we say, if it's square, we're going to get you a square gasket. Some channels are rounded. Some different machine manufacturers will put in a rounded channel. So maybe we'll put a round cord in there. But really, each machine is a little bit different. We can help you out to figure out which one's going to be best for you. Some examples that we'll look at over the years as we go to customers that have part hold challenges and everything looks good. But as we start to take the spoil board off and start to experiment or explore as to why they can't get vacuum part hold, we'll start to see things like this. And this was a customer that had a pretty major gap right in his grid, trying to make a grid table, and that gap, combining those two boards, was the massive loss of air that he was getting. He wasn't getting that vacuum, lack of air. He was just trying to use that wind of a vacuum cleaner versus a void of air. So this gap here caused a problem. Other problems that some shops may deal with, very often we hear of customers who are screwing down their spoil board to the table. And sometimes if they take those screws out, those extraction marks will cause some irregularity in the table surface, and that spoil board can't flush out. So again, there's more gap opportunity for that vacuum to escape, and that's what we don't want. So we sanded down that table, caused it flat, caused it flush to go against that table. Much better vacuum performance once we did that. So Margot will put a few downloads. We have a download throughout the presentation. She'll give a few out. Right now, she'll make a flyer, our line card for our grid gasket products available in the download section of the webinar now. So that'll be available to you. Feel free to grab that and pass it along. So as you download these, let's take a look here. For all the companies using gasket under their spoil boards, we always talk about, many folks are doing that, but I've yet to meet the company that has invested in a CNC router in order to hold spoil boards, right? We're always after parts. So anybody that gaskets for their spoilboard, I think, is doing a fantastic job. But maybe there's an opportunity here to go a little bit further. And in that regard, we'll launch another poll here. We have a poll. What is vacuum clamping? That's what we're about to get into. It's one thing to gasket under your spoilboard, but now let's deal with parts. And vacuum clamping of parts is really the science change that we're trying to get into our customer shops. And curious what you guys know about vacuum clamping, how it works. And there's a couple of questions that we'll put out to you and see what you think. And I will close my screen here. And fantastic. We'll look forward to seeing some of those results as they come in. Maybe we can share them a little bit towards the end of the presentation as well.
So we got quite a few responses here, Mike, and it looks like they've been listening to the words you've been speaking, because everyone has answered B, using a vacuum chamber to create negative air pressure under parts. So good thing, good listening, everybody, and let's hear a little bit more about vacuum clamping from Mike.
And this will all be on the test later, so good job, everybody. So that brings us to step 2, right? If we can get our spoil board sealed, prevent leak between the table and the spoil board, there's that gap that exists. We showed you with that red arrow. A small gap can lead to great vacuum loss, so we want to seal that with gasket. Pretty much every router manufacturer sends their tables out with gasket to make sure that table is airtight, the spoil board is airtight, but it's now your responsibility for your parts. And how do we make the parts airtight? Because there's a gap now that exists, maybe equally sized, larger, smaller, but there's a gap that exists between the spoil board and your part, and that's what we're going to get into here. Step 2 of a 2-step process is now the spoil board and the part. Let's get some vacuum clamping in. So easiest way that we determine what product line we're going to recommend to a customer is ask them the parts that you're doing. Are you better off using a spoil board or a dedicated fixture? Because I think those are 2 different things. A spoil board to me is a board that is intending to be spoiled. We're going to spoil it. It's a consumable surface because we have so many different parts to make. We have that sacrificial cutting board under your parts that you chew into throughout the day, fly cut it every once in a while when vacuum performance degrades. Typically, all the wormholes that go into an MDF spoil board, a porous board, lead to some of that leak. So you need to fly cut to improve the vacuum performance, because it's the leak that is occurring through all those wormholes that require that improvement. So that is an MDF spoil board, very commonly used throughout the industry, probably the most commonly used application for CNC routers throughout the world. As opposed to a dedicated fixture. And a dedicated fixture is a dedicated board, and I think the best ones are airtight. Let's make it out of Baltic birch or a HDPE material that doesn't leak vacuum, doesn't leak through the sides, doesn't leak through the tool channel. Some people will edge band their spoil boards. We'll talk about that more a little bit in a moment. But the airtight dedicated fixture, if we spend some time to make an airtight fixture, most customers will tell us the time that they invest in making that fixture more than makes up for itself in the time they save once they start to put those parts into production and really get more parts, less time, eliminate the onion skins, the tabs, the low feed rates. So great option for those production shops is to do the dedicated fixture. So that will bring me to screen here, going through the difference between downdrafting and vacuum clamping, because that's really kind of what we're going to get into here. And downdrafting through an MDF spoil board versus vacuum clamping, I'm going to let Alex here take over a little bit to maybe talk about the science between the 2.
Thanks, Mike. Appreciate that. So as we illustrate here, these are comparisons between downdrafting and vacuum clamping. And I think what's great to do here is maybe paint a scenario for our attendees here that many of whom might be nodding their head a little bit when we talk about this. So when we looked at the polls and who's in what industry, many of these attendees here are running nested programs. And no matter what software you're using, once you've laid out your project, you've oriented your parts, you're ready to go. You put your sheet good on your CNC and you hit go for that project. Well, at that time, and that time only, if you have a vacuum gauge or otherwise, it would register its peak value during that project and only at that time. Once you begin to cut, the vacuum gauge is going to decrease and decrease over time and through that project. And the reason for this, of course, is we keep talking about physics. Well, air is a fluid, and physics dictate that air is going to travel always to the path of least resistance. So when we look at the vacuum gauge and when it is at that peak value at the beginning of that project, in my humble opinion, that's not registering or indicating vacuum hold on the part. That's actually indicating resistance to the vacuum system. So when you put that sheet on there, you've created a dam, and that pump is struggling to pull air through that open MDF. And as we cut, we're opening up channels and we're creating less resistance, and that's where that air is going to flow. So downdrafting, it's inherently difficult. It's almost flawed, I guess, by comparison to vacuum clamping, because the more that we cut, the harder it is to hold parts. And the smaller the part, the greater the challenge. And I'm going to share a quick video here this video has been shared a lot of times, but maybe some of you attendees haven't seen this yet. But it really illustrates sort of this aha moment. And here we have Mike. We're at a customer's facility, and we have a test gauge here that we're using. And here we put a typical drawer front on the open MDF. All that air is flowing around it. We're turning on the pumps, and we're trying to see how much effort or pressure it's going to take. It was actually 21 pounds at its peak to kick that part out at its fulcrum. So that's downdrafting. Now, what we're doing very quickly, very easily, in just a matter of moments, we're simply using a gasket to seal up against the part. And that gasket's not only sealing, but it's creating that vacuum cavity or that vacuum chamber. So if we're able to remove just micrograms worth of air underneath that part, turn that on, and then let's take a look at the difference. We went up to 120 pounds of force to move that part compared to simple downdrafting. And that is the power of vacuum clamping. That's the physics really that we employ in all of the work that we do. So as we move forward and going through this entire presentation, it's really focusing on the science behind what we do, and hopefully that resonates with many of you and is formative as well. So I'm going to pass this back over to Mike for him to go ahead and continue out this presentation.
Alex, thank you. Just to give a quick visual about what that vacuum clamping is. You can see a massive difference between downdrafting through that MDF spoil board and then introducing that gasket to create the cavity that we're going to pull the air from to produce that air pressure differential. So we'll get into a whole bunch of different ways to do it, but the science that is taking advantage of is always the same. Create the space, pull the air from, vacuum to hold on and clamp onto those parts. It creates more of a suction cup than just the wind of a downdraft through an MDF. So we'll get into it a little bit. And as we said earlier, there are no one-size-fits-all options that we have, and knowing that everybody's in different industry, some of these products may not be relevant to your particular shop, but we're going to go over a bunch of them to help you guys determine which one's going to be best for you. So first ones we'll get into are the two different product groups that we have available for those doing dedicated fixtures. A lot of our furniture shops, maybe some guitar shops, anyone that's doing production runs, I think can be benefited by using dedicated fixture ideas. So we have the inboard and the cover gasket. First one we'll do is our inboard gasketing. In my opinion, I believe that inboard gasket is the premier way to do this. A gasket in the channel is going to last longer. It's going to pull the part flush up against the fixture. There's a lot of advantages to an inboard gasket when you get into some of these. And as I said, it's intended for those shops doing production runs. If somebody has a very tight Z depth tolerance that they're looking to hold, inboard is a great solution for that because it will zero out while it disappears into the channel. Also, anyone that's looking for the longest lasting gasket solution. The fact that it is in a channel, much like the gasket under your spoil board, it's in a channel. It's only going to compress by the height of that channel. So it tends to last a little bit longer. It never really gets maxed out. So extends its lifetime for those production pieces. Some of the rules of thumb that we talk to customers about, we always mention a 3-to-1 ratio is best when putting the gasket into a channel. Probably 1/4 inch by 1/4 inch gasket is our most common product, our CR 2525. And we usually recommend routing a channel 3/16 deep to leave that 1/16 above. Some customers need a little bit more than a 1/16 of an inch sticking above if they have a very warped or varied surface material. And if they need more than a 1/16 of an inch, maybe we'll recommend our CR 50/50, which is a half by half, and route that channel 3/8 inch deep to leave that 1/4 above. So depending on the product, how much you want to leave above, but the 3-to-1 ratio is the number we've found to lead to longest lasting gasket material for those production pieces. We also want to make sure that when we do go to a dedicated fixture environment, the fact that we're using a non-porous material, there is no universal vacuum draft, right? When we're using an MDF board, everything is held by default. Whether it's good or bad, maybe is a different question, but MDF downdrafting universally tries to hold everything. Whereas when we go to a dedicated fixture that's non-porous, it's the opposite. Universally, it's not holding it. So we need to create vacuum for not only the parts, but maybe also the waste pieces and the offcuts, and make sure those things don't go flying off the table. I think this is a great example of how I would do a dedicated fixture. Take the existing CAD program that you have that's going to be used for the tooling path, and then just to the inside of that tool path, now offset it and run your gasket channel. And then just to the inside of the gasket channel, create a third channel, which is your vacuum channel. And if we can run all 3 of those channels parallel to each other with a vacuum source for the vacuum, because the tooling is what's causing the carnage, right? The tooling pushing its way through the part is what's causing things to shift. So the closer that we can get that vacuum clamp to the tooling is what's going to lead to the most success in holding those parts. We also recommend using a chamfer bit to create the channel for your dedicated fixture idea. All-Star has created a line of specialty tools for chamfer bits for different size material, quarter by quarter, quarter by 3/8, quarter by half-inch gasket. We always recommend some of our chamfer bits. The 25/25, 25/38, and 25/50 represent the gasket size that you get. And what that does, it just creates a slight chamfer at the top of the channel, so that gasket has an ability to zero out. You don't want it to pinch between the 2 surfaces, so that would do a great job of allowing that gasket a little bit extra wiggle room, and we always recommend using those tools for that. That being said, what we're going to do is send it over to Daniel. Daniel's going to do some live demos here, doing some of this inboard gasket to show some of the benefits of the chamfer tooling. Daniel, take it away.
Mike, thank you very much. So here we are with our vacuum truck. This is a collaborative effort to answer some of those desktop CNC routers that may not have vacuum. Those ShopBots, the Avids, the potential Onefinities, where a customer does not have a vacuum table but would like to add vacuum to their parts hold. In this example here, we have grid gasket running down the channels surrounding these 6 vacuum ports. This is going to represent our 4x8, 5x10 work surface, our vacuum plenum right here. This is our standard MDF. This is 1/4 inch for us just for this vacuum truck. But this is what we're going to be working with for the most part. All of us are very familiar with this. In a production type setting, there is vacuum right now. In a production type setting, if we have to do 1,000 of these parts, what tends to happen is as we cut away from the main sheet of material, we'll end up having to do onion skins or tabs to hold small parts like this. As you can see, even with the vacuum on, the part is still moving. In fact, if I take my pressure gauge right here and give you an example, we are at 2.6 pounds of pressure is all it takes. So you can imagine on a large production with a tool going around the outer perimeter of the part, that could cause parts to shift, potentially kick off, be a hazard. What we want to do is seal the part, seal the space underneath the part, and create a production type model so we can lay different sheets down and continue to run without having to worry about parts shifting. So what I'm going to do is replace this with a non-porous material. In this particular case, this is Baltic birch. You can see, as Mike mentioned, we have our chamfer bit here. This was created to create a channel for the gasket to reside in. We have an outer tool path for where the profile of our part is going to be cut. Independent vacuum ports going directly to our vacuum plenum with a space for the vacuum to be pulled as well. In this example, These 3 vacuum ports are closed off underneath. We are focused primarily on this single vacuum port right here. We have our part in place. And a leak somewhere. There we go. We now have a part in place. There was a leak underneath the grid gasket. Now that that is solved, starting with the foundation of the house, of course, the pressure to move the part has jumped exponentially. I'm now at 66 pounds of pressure, and I was unable to move that part. So you can imagine the carnage of the tool path of the router bit that you want these parts to be secured in place. And this allows us to run multiple sheets without having to worry about onion skins, tabs that we have to clean up later. I'm going to send it back over to Mike. Thank you very much.
Daniel, fantastic job. I actually enjoyed the fact that you had a little tough time getting that initial vacuum clamp because that shows that if there's a little bit of a leak going on, that really solid clamp doesn't take effect, right? We're not getting vacuum because there was a leak somewhere and we had to reset that jig to make sure that it was airtight all the way around. And that's where we had the success. So great job of showing that all situations need to be accounted for and all leak needs to be eliminated. So that was a great job of showing some of those concepts. Here are some real world examples that customers have sent us over the years. Knife handles, obviously a very small part. This customer was attempting to cut knife handles through an MDF spoil board and was having 0 success. So he called us, we talked him through building a dedicated fixture for himself and very happy that he found us in order to get these jobs done. Another customer, Poly Furniture, always a difficult product to hold, to cut just because it's so dense and there's varied surfaces. Some of the times that man-made grain in the surface creates a great deal of gap and that's where all that vacuum is escaping. So by creating a gasket seal all the way around there, much easier to clamp those pieces. And this customer, big user of our inboard gasket material to get all that Poly Furniture out his door. We have another furniture shop made a fixture out of a melamine. He even has these fixture parts raised up a little bit so we can do some profile work around the edge. But again, an airtight fixture. You can see the vacuum source, the vacuum channels running right parallel with the gasket path. So great options for those folks who are doing the production runs. And I think Margot's got some downloads available now for all those that are interested in inboard gasket, one of our line cards on inboard gasket options and some more resources on that. So that is the inboard gasket solution. Another great option came about based on another customer request, right? We're not smart enough around here to make our own products. It's you guys, the customers, that explain what your challenges are, and we work with you to try to figure out how we can address that. And as a result, that's where the product line has evolved from. So one of the questions that our customers had for us was, hey, can you guys make this gasket narrower? And we couldn't figure out why you wanted it so narrow. And it's basically because he was doing really small parts. And what he wanted to do was get that gasket in and out of those tight areas. And he thought the thinner way to do it would be better. But as opposed to a thinner gasket, narrower, we decided to try out some cover gasket. And that's where this product line came about. And it's a great solution for those folks with parts with limited surface area. It's really intended for, again, still we're maintaining in the dedicated fixture environment. So those production run pieces, but maybe they're not large furniture parts. Maybe they're small, tight angles. I always like to use an example of a star from our customers because star, we're all star, and all those 5 points of the star are very tight angles that would be difficult to gasket for with an inboard gasket solution. So limited surface area, tight angles, or parts with excess holes. You can see this was a Christmas ornament that had a hole in the top. If your part has a hole, and if you have a gasket perimeter on the outside, and then you put your hole in there, your vacuum chamber area has been compromised. So you're not going to get a vacuum clamp with just a perimeter in a part with a hole in it. So you need to account for that hole to keep that vacuum secure. So again, cover gasket, a great solution for parts with a lot of holes because you can account for that. And again, back to the dedicated, or still in the dedicated fixture environment, we always recommend folks use the full sheet, and we have some engraving tools cutting out, and you can use the existing CAD that you have. So sometimes the router itself can do a great deal of the fixture building for you because you're just offsetting some programs and downsizing to get your vacuum chamber area for your particular part. The rules of thumb that we have, we always say that the thinner the better. The thinner the gasket, the less deflection is going to cause, the less variance it'll create, the less jello effect it'll have. So the thinner the better, but of course you need to have enough thickness to counteract for the variance in your particular material. So the more variance, the thicker it needs to be. Here is the engraving tool that we mentioned. Great solution. I think we have one here, part of our custom tooling line. All-Star has the engraving tool to create all aspects of the cover gasket lines that you want to do. You can certainly use a 1/4-inch flat bottom bit, for instance, to cut through your cover gasket, but we find sometimes it's one edge of that path will be clean, the other will be a little bit rougher, and you know, that rough edge of the tool path doesn't necessarily create a problem vacuum-wise, but in these production environments, sheets are coming on, parts are coming off, sheets on, parts off. So sometimes that bird edge of gasket can cause some problems as we're trying to put stuff on and off. So an engraving tool, great way to make a nice clean edge. And sometimes customers will even create their gasket channel a little bit wider than the tool that they're going to use. So a great solution for those kinds of shops. Some cover gasket examples. Well, let me go back to this one here real quick. I like this one. Another example, guy had 4 holes in his parts. In the 4 corners. So those are accounted for in the fixture on the right-hand side. Another example of a hole and a gasketed fixture for these small parts. So that is our cover gasket. I think Margot is going to make a download available for the cover gasket customers that have an interest in that. So that download should be available now for you. So that leads us to the next customer request that we had, further product development, because we have a lot of customers out there that aren't in production environments, custom stuff, short runs. So they don't have the time nor the interest in making a dedicated fixture, but how can I get the vacuum clamp benefits without a dedicated fixture? And for those customers, we have 2 products for the spoilboard improvement. We have our onboard gasket and our tile gaskets. Both are great options. Let's take a look at, we'll start out with our onboard gasket. And the video that Alex showed earlier over at a customer doing the push-pull gauge, this was a perfect example of an onboard. Real quick, real easy, doesn't take up a whole bunch of time just to stick that down onto the spoilboard to make that vacuum clamp area. The onboard gasket intended for all those that want to make that vacuum clamp concept without the dedicated fixture investment. And it's a great way to do that. Quick way to do parts, maybe some slabs that you want to do some surface work to. So all those things you want to do, quick works, prototypes, great solution. Onboard gasket is that spoil board. It's a board that we're going to spoil, quick setups. And again, the CAD fixturing or the CAD design can do a lot of the tool layout. Some of our customers over the years, what they've done is they will scar the tool path into the spoil board and then just lay this gasket to the inside of that. As a result of hearing that, we have created yet another custom tool for our customers to take advantage of, which is our marker tools. The marker tool allows a customer to use the CNC to put a pen mark on the spoil board to dictate where that gasket should be laid out. We can see a customer here laying out some gasket. And the tooling, and the advantage of doing this way is, as we mentioned earlier, the more you use a spoil board, the more wormholes that you put in there creates more and more leak. So customers who use the pen to stick gasket onto their spoil board in the exact right spot are also lifting their parts off the spoil board by a couple of thousandths of an inch. And as a result, if they can dial in their Z, these customers using a MDF spoil board never chew into that spoil board, and we're not spoiling it as much, not consuming it as much as without that gap, plus the advantage of massive massive vacuum improvement. So when it comes to onboard gasket options, we have a few different thicknesses. Again, the thinner, the better. The far left, the 1/32 inch thickness, most common for our plastics customers, just because there's very little variance in plastic. The 1/16 customers are more commonly the ones in the middle there, the 1/16. And then we also have an 1/8 inch, typically for those customers doing varied stuff, maybe the poly furniture or a warped plywood, different ideas. The more variance you have, the thicker that gasket needs to be. Also, the firmer, the better. We have a bunch of different densities for all these products. Typically, our low density products are meant for low vacuum systems. Luckily, the science of vacuum clamping is universal, but the smaller the vacuum pump, the less power it has, the softer that foam needs to be. But we still create a solid clamp. It just needs to be a softer foam. Typically, the industrial CNC machines in the marketplace these days will use our medium density. That's the most common. And we have firm density for very heavyweight material. But the firmer, the better, because if you can compress it that first time, it's not going to get any harder over the years. And you always want to make sure that Z depth is accounted for, because it is a surface mounted material. And some onboard examples that customers have sent us over the years. We've got a guy who was having a tough time holding some of these cutting boards. So a quick stick down of gasket material allowed him to do these parts much quicker, much easier. And same kind of idea with this pizza peel. Customer had a tough time with those narrow handles. So quick application of some gasket material certainly aided them in clamping that part versus downdrafting it. So I think that does our onboard gasket rundown. Margot has some handouts available for that concept of our onboard gasket. So that will bring us to one final concept that customers have requested from us over the years. How can I get vacuum clamping on my always changing parts, always custom? What is the best way to achieve vacuum clamping in that kind of environment? And that is where our tile gasket material came from. Tile gasket is pretty unique, pretty inventive on our end, and there's a lot of interest in it. And before we get into some of the benefits that tile gasket touches upon, we've got another poll question that I want to get into real quick, which is along the ideas of how many of you out there seal the edge of your spoil board? Whether it be painting it or running it through the edge bander or putting some kind of water glue mix onto the edge of the spoil board. I'd be curious to hear how many will edge seal the edge of their spoil board for whatever reason. And Margaret,
it looks like we've got about half and half, yes and no. And as Mike's going to explain, tile gasket somewhat seals the top of your spoil board, but you're still going to get leak laterally on the edge. So sealing the side of your spoil board is very important. We're still about 50-50 on yes and no. So Mike's going to talk a little bit more about our edge seal tape. And I'm going to close this poll up.
Right, Margaret, thank you very much. And it's interesting. I always like to ask that question of customers. Are you guys edge banding or sealing the edge of your spoil board? And I ask them, why do you do that? And is to prevent the leak out of the lateral sides of the spoil board. And I get that. I approve of it. I think it's a great idea because all leak is a problem. The more leak we can prevent, the better. So as a result, we've created a new product here, what we call our Edge Seal Tape. The Edge Seal Tape is a quick and easy way to edge band, in a way, your spoil board and get that airtight mentality into the side of the spoil board. Doesn't take any time to dry. Don't have to bring it over to the edge bander or have to buy an edge bander if you don't have one. So Edge Seal Tape, great option. We pre-cut it to 3/4 inch wide for those 3/4 inch MDFs. So product, if anyone's interested, that something that you can have. But I thought this was a great time to talk about Edge Seal Tape because, well, let me go back here for a second. Edge Seal Tape is preventing leak out of the side of the spoil board. And I, like I say, I think it's a great idea. But when we look at, let's say, a 5x10 MDF spoil board, when we're looking at the 3/4 inch wall that goes all the way around, the overall surface area that the 3/4 inch edge of that spoil board represents is about 1.5 to 2% of the surface area. The vast majority of your porous MDF spoil board is the top, the 5x10 area. But we can't really paint the edge of the spoil board, right? You can't throw that through the edge bander because we need to get vacuum through it. So that is where the tile gasket concept came about, is that the tile gasket is now essentially sealing the spoil board. Tile gasket is intended for all those who are doing random stuff, always changing. They need that spoil board environment. They need that consumable surface to go into, always changing, not in the dedicated fixture environment. And the tile gasket is a great solution to both seal and clamp at the same time. It is producing the leak prevention because the gasket material is 95% gasket and only 5% hole. So we've sealed 95% of the top of that spoil board. And all those thousands and thousands of 1/4 inch holes that are left behind are the vacuum chamber areas now. We don't get vacuum chamber in just a downdraft environment. We have thousands of little mini suction cups holding on to a sheet. Now, maybe a 1/4 inch hole isn't enough to hold on to your part, but thousands of them working together in a random area, it really does a massive job in holding parts in place, holding the sheet in place as you cut it. So great solution for those folks for that spoil board environment, looking for vacuum improvement. We always talk about the rules of thumb. Again, 5% of it is exposed vacuum area. The other 95% is sealed. That vacuum pressure makes its way through those holes. Great solution. This becomes the new consumable material. So as a result of the tile gasket being the new consumable surface, probably the most important thing we talk to our customers about, every customer that has ever tried this is blown away with the massive vacuum clamping improvement that they get. That is never a question. The question becomes, we're not in the business of trying to sell magic tricks. We're trying to sell clamping ability, production aids, and the customers who get longevity out of this are the ones that are the happiest with it. We don't want them to be chewing through this because it is a consumable, but the folks that get a lot of use out of it, a lot of parts is what we're trying to produce. And as a result, here's a customer that sent us some photos. This customer applied his tile gasket sets to both of his, he's got a couple of Lagunas here, covered his spoil board, and his page here says that he is at over 5,600. It says parts, but he confirmed to us that is sheets of material, 5,600 sheets, hundreds and hundreds of hours worth of machine time on one set of tiles. And that the way that he was able to achieve this was to really dial in that Z, not cut through the gasket, but cut through the part and really get the maximum vacuum performance out of the machine. And what this customer was able to do was eliminate the need to use tabs, eliminate the need for onion skin cuts. He's also eliminated the need to fly cut his spoil board, right? If we keep that Z tight throughout these 500 hours of machine time, he doesn't have to fly cut the spoil board at all. And I'm not sure how many times you guys are watching your CNC fly cut. It's not making you any money at that point. As my wife says, you want to make your machine make you money, not cost you money. Fly cutting is costing you money. You want to be making parts. And the less fly cutting we do, that's the way to do it. Let's dial in that Z on the tile gasket material. This is our new version of our tile gasket. It came out earlier this year at the AWFS trade show. We took the feedback from our customers and changed a few things. The tiles are now larger, 2x2, so it takes a little bit less man hours to get them out onto the table, or man minutes maybe. And we also have offset the hole pattern so it's not squared up. Our version 1 was kind of squared up like a pegboard in your garage. The new set, a little bit offset, so all of our cabinet shops that really enjoy using this material, as they cut those square cabinets, they don't go right over those tool paths. The offset creates a little bit perfect imperfection and a little bit more randomness to what size parts you're cutting out. So that will bring me to another opportunity to throw it over to Daniel. We'll give you a quick rundown of some of these tile gasket performance differences. Daniel?
Mike, thank you very much. Okay, so again, we have the familiarity of our vacuum plenum here. This is going to represent an open spoil board. Obviously, our tile gasket covering this half here. When we turn the vacuum on, getting to those small, oddly shaped parts, you can see that there is vacuum on this part once again. But in this instance, we're pulling draft. We're hoping that we're pulling more CFM than we're losing outside of the part right here. So we're just pulling air directly through the substrate of this MDF spoil board. Again, taking my pressure meter, little bit better on the pressure here. We're at 7.7 pounds of pressure, and that has to do with the fact that most of the surface is covered with our tile gasket. I'm going to reset this for 0, pick up this part here. And the best part about our tile gasket is that random patterns of that 70-degree offset allow for the maximum amount of vacuum ports to be underneath the single part. This acrylic sheet here is a perfect example. You can see how many independent pockets fall across the single surface here. So oddly shaped parts, changing parts, small sizes. We have success with parts up to 3 inches by 3 inches, but I'm up to 51 pounds of pressure now just by using this tile gasket, sealing off a good surface, and then concentrating those vacuum ports, essentially creating micro suction cups across my oddly shaped or small sized parts. So that is how the concept of the tile gasket works, let alone the friction of the mat as the material compresses into it. So this is a great concept for those that are doing changing part shapes, sizes, different materials. If you're switching between melamine, acrylic, plywoods, anything like that, this is going to be a great proof of concept for those with changing parts instead of doing a dedicated fixture. Mike, back to you.
Daniel, fantastic. Thank you for giving that a show. And yeah, that's the benefit of tile gasket leak prevention, as well as vacuum clamping ability that is not always available in just simple downdrafting. So that brings us to a couple of examples customers have sent us. Again, another Laguna, just coincidentally, doing parts. It was another customer that get massive use out of one set of tiles. Well, let me go back to this one real quick. And Margot probably has some downloads available now for our tile gasket line card. Should be available in the download section. But one thing I also wanted to bring up was this unique kind of concept. So our customers, like I say, our customers are better at this stuff than we are sometimes. And we sent tile gasket out to both of these customers, thinking that they were going to be using it in a kind of a spoilboard environment, just always cutting random pieces. But this customer created, in a way, a dedicated fixture concept for his production pieces using tile gasket products. And what I found interesting was this: the customers, we always follow up with our new customers, make sure things are going well. And when we followed up with these customers, like how things going with you, you doing this in a spoilboard environment, they told us they did a dedicated fixture production run piece, and they spent very little time in creating that dedicated fixture. They didn't have to do any extra CAD work. They didn't have to create the vacuum channels or the gasket channels. The fact that they can just stick this stuff down and then just get that same part over and over and over again was a great solution for those guys that they didn't have before. So that brings us to the end. That at least the 5 different product groups that, there is no ever end. There's always stuff we could go over, but we're at that hour mark. But those are the 5 products that we've addressed to create better vacuum performance on CNC routers. Only company in the industry doing this kind of work. The grid gasket for the grid itself. We have the cover gasket, the inboard gasket for those dedicated fixtures, the tile gasket and the onboard gasket for kind of the spoilboard setups. All our options, give us a call. Let us know what you think is going to be the best solution for you. And now that we've completed that, let me send it back to Alex. He's got some quick options for you, and we'll wrap it up.
Yeah, thanks, Mike. Excuse me. So we know that parts holding is only part of the equation with production on your CNC machine. We've relied on certain knowledge bases in the industry to help our clients as well. And software is that other component to productivity. Learn Your CNC is a great resource. And Kyle Eli, he's one of the lead instructors and the owner of Learn Your CNC. Been a valuable asset to our clients, and he's been gracious enough to provide a 10% discount for any of his learning classes. And you'll find that in the Q&A or the chat area. It's going to be All-Star CNC if you visit his store, and he'll apply, again, that 10% discount to any of the learning classes that we have there. So without further ado, and wrapping that up, I believe we've got a promotion and a giveaway that Margot is going to initiate here. So we've got a special offer for any of our attendees today. If you use code VAC10, and this link here will take you directly to our store. You won't leave the webinar, but it'll take you directly to the store. You'll receive 10% off of any and all of your orders for the next 24 hours. And we've got a pretty cool Math is Hard, but Vacuum Clamping Isn't t-shirt. It shows the mathematical equation for vacuum clamping and how we actually develop the science. So you can be pretty cool in your shop, teaching people what vacuum clamping is with the front of your t-shirt. Great. And we've got a little giveaway going on. Margot is going to start our little giveaway here. We're going to give away a few of our cool trucker caps. We're going to pick 3 people at random.
Oh, wow. Yeah.
Okay. Michael Yoger, hope I pronounced that correctly. Patrick Vanderbilt and Aaron Lemke. We'll be reaching out to you guys and sending off one of our cool trucker all-star CNC trucker caps. You'll be the envy of all the other CNC operators that are out there. So again, thank you everybody for taking the time out of the day. We've had a great attendance here. We've had a number of questions come through the chat area and also the Q&A. Margot's going to help moderate that. We're going to, I think, tackle a few important topics that have come about, some additional things maybe perhaps we didn't cover, and Mike or I will try to answer those as best as possible. Margot, do you have any ones that you saw that were particularly interesting that we should share with the group?
I do have a few questions here. We're going to start with a question from Brian, who said, my shop's at 5,000 feet altitude. Love to see anything particular to high altitude vacuum use. Mike, do you have some explanation of that?
Sure. We obviously can't change the thin air there at your high elevation. So any customer that's at high elevation has some larger challenges than somebody in Miami. The fact that you're at high elevation, and we talk about vacuum clamping and air pressure differential, the air pressure in high altitude is less than it is at low altitude. So, and there's no getting around that. So the high altitude customers do have greater challenges, and as a result are probably even quicker to rely on gasket solutions than somebody that may not. I've always said, if you can downdraft and cut parts in that manner quickly and efficiently, why not do it that way? I'm not trying to tell everyone that they need gasket solutions. If you can cut your parts without adding a gasket solution, great. But the folks that do need extra help and need a plan B, that's where these gasket tools become available, and higher elevation shops take more advantage of these tools sometimes because they're available to them. And like I said, there's really nothing we can do about your elevation thin air, but the more products that we do to create massive air pressure differential, the more we can take advantage of lack of air under the part.
I'm going to add to that too, Mike. Those are good points. Now, there are 2 things in physics that are going to affect air density, and that's number 1, temperature, and altitude. So in terms of on a molecular basis, colder air is going to be more dense, and air at lower altitudes will be more dense. So that being said, people who have parts holding issues at higher elevations will probably see even a greater advantage with vacuum clamping, not relying on the density of the air to be pulling CFM, because with vacuum clamping, we're not concerned with the volume of air that we're pulling through the system. It's really more of the strength of the vacuum. So once we've sealed underneath that part and we've evacuated a little bit of the air, again, even micrograms at times, that's where that air pressure differential happens.
Okay, great. Thanks, guys. Brian, I hope that was helpful. Of course, we're always here to chat on the phone as well or via email. Another one is Seth asks for you to talk a little bit about gasket use on a pod and rail system.
Sure. The science of vacuum clamping is the same on pod and rail systems. The majority of our customers probably have flat tables, just because the flat table, the nesting tables, use full sheets, whereas the pod and rail, typically the gasket is just in the pod itself. Same rules apply. We think square gasket is better than round. Tell us the channel size that you have in your pods, width and depth, and we can get a proper gasket in there to seal the pod properly. But what we've also helped customers achieve, sometimes we'll take a dedicated fixture kind of material, a Baltic birch, an HDPE, and they can set a fixture on top of maybe 2 to 3 pods and create a flat table environment in their pod and rail system. So if you can get that maybe a man-made grid that you can put onto some pods, you can get back into this scenario where you have a flat table and use all those different concepts that we just went over that are usually meant for that flat table system, but you can do it on a pod. I hope that is the answer to the question.
Great, thanks, Mike. Seth, hope that was helpful. And on to another Brian, different Brian though. How to keep parts from getting pulled up into the dust collection hood when using upcut end mills?
To me, that would indicate that the vacuum performance isn't working well enough. I think that's really the main challenge that you're going to have if parts are being sucked up in the dust collector, is that they're not being held down strong enough. So I think it just goes back to all these different things that we've mentioned. Maybe make sure we've changed out the grid gasket underneath that spoil board, because in my opinion, there's probably some kind of leak going on somewhere. And if we can eliminate that leak, that vacuum pump is just going to increase in performance. As we eliminate leak, performance increases. That's as easy as that. So if that vacuum is sucking up your parts in the dust collector, I think you really want to make sure that everything under the spoil board is sealed up properly.
Yeah, I'll add one last comment to that. We just had a client a couple of days ago who was on social media. And one thing that we love about the CNC router community is that through the various forums, Facebook pages, Instagram or otherwise, people really want to help one another. And somebody had complained about not knowing about All-Star, complained about their small parts getting sucked up into their vacuum system. And somebody recommended All-Star. He reached out to us. We hooked him up with a tile gasket, and he's never had better parts holding, and he has no issues with sucking up those parts. So yeah, Mike, you're absolutely right. If parts are being held tight, they're not going to go anywhere, and certainly not from that vacuum, the dust collection system.
Good point from both you gentlemen. Definitely, if your part's not being held down to the spoil board table, then you definitely have vacuum issues underneath. So Randall has a question here. How would you explain tile gasket installation best practices?
Great question. Tile gasket, like we say, longevity of the tile gasket, Z depth control is so crucial to those customers to get longevity out of it. And we recommend a few different things for tile gasket installation. First off, fresh spoil board. Let's get a fly cut spoil board, wipe it down, wipe it clean, ready for those peel and stick tile gaskets to be laid down. Once those are laid down, in our opinion, it's a great idea to screw the spoil board down to your grid table. All-Star will be introducing soon a set of screw down tools that you can use to keep that thing down to the grid. That prevents that lifting and swelling, keep everything consistent. But if you don't have to do that, the idea is just to keep that spoil board fresh, clean, seal around the edge to keep that as consistent as possible. And what I'd recommend is really dialing in that Z in terms of the depth of the cut. We were at a shop that he probably gave us the best way to do it. What he did is he set out the whole set of tiles, pulled his vacuum down. He set his Z to the top of the tile gasket material. When that vacuum engages, the gasket will compress to a certain degree. I can't give you an exact number because all those variables that we talked about at the beginning, strength of the vacuum, elevation, weight of material, all these things will determine how much it actually compresses. So what he did was he set the Z to the top of the gasket, ran a test pattern. He ended up with a little bit of an onion skin. He calipered that onion skin and then reset his Z a little bit deeper to account for that. And it was a great way to, and at the end of that, he was barely touching the gasket, but he was also through the part. So I think that's probably the best way to get that set up and dialed in. Alex, I'm not sure if you have anything to add to that.
Yeah, Mike, I think that's great. What you mentioned, I think, is apropos in that, we talked about air density, vacuum systems, vacuum strength, and materials. People ask us, well, how, with adjusting the Z, what numbers should I use? And those are going to change based on the project and the setup, et cetera. So, again, if you zero out at the top of the tiles, mark that as Z0, do a side profile cut on a piece of test material and mic that out, use a pair of calipers, and then just add a thou or two. You're going to get a nice clean through cut, and you're going to be barely scoring into the tile gaskets. Now, our clients ask us, whenever they learn about tile gasket or it's presented to them, the very first question they ask every time pretty much is, well, how long is it going to last? And not to sound trite, but you guys get to decide that. The operators get to decide it. So it's a bit of a paradigm shift when you're running from an open spoil board downdrafting, and now you've changed. It's a paradigm shift to using vacuum clamping. We want to preserve those tile gaskets. So the least amount that you can score through it and cut through it, by the way, they are designed to be cut and scored through. You can actually see that little Q&A image right there. But the least amount that you go through it, the longer the tiles will last. And we saw an image where we had thousands of sheets, almost 6,000 sheets, if we're on the same set of tile gaskets. So that's really important. And then we're actually going through some live chats right now. Frederick Calatafin was asking about fly cutting. And, the tile gasket, as we mentioned during the presentation too, this becomes your new spoil surface. And you're not going to need to fly cut your spoil board virtually any longer, as long as you take good care of your tile gasket. And when they are consumed, because there is no gasket on the planet, it isn't a consumable, they will wear out over time. Simply fly cut it off and apply a new set of tile gaskets. So, Frederick, you asked, like you guys fly cut your spoil board and eventually gets down and down and down before you replace it. Well, when you use the tile gasket, you're not going to be removing all those layers, just a little bit to get a nice fresh, clean surface on the tile gasket before you lay that out. And that's the same thing also with the edge tape too, right? Once you put on that edge tape, it can be cut, right? But you're not going to be wearing down that spoil board surface as you normally would through downdrafting.
Okay, great, guys. Hopefully that helped you guys out understanding best practices for tile gasket installation. And one more here before we wrap up. We're just coming up to our hour-and-a-half mark here. Todd asked you to talk about vacuum pump size.
Great question. Great question, because I think vacuum pump size is not as important as some may lead you to believe. If somebody comes into your shop and says you need to buy a bigger vacuum pump in order to do this, I completely disagree with them. I think the size of the pump is less important than how you're using it. We've dealt with many customers over the years that have said they've invested in that bigger pump that they were told to invest in and still are having problems holding their parts. So they do some more research and they eventually find us and we get them some gasket solutions, and now they're holding parts. Because if you got a hole in your boat, do you want to get a bigger bilge pump, or should we fix the hole, right? Let's fix the holes and eliminate the leak. And then sometimes a very small vacuum system, Daniel's demos that he was doing, I think we got a 0.5 horsepower pump, not a very big pump, but we got massive clamping ability with that small pump because we've sealed everything and it's an airtight solution. So a bigger pump, someone tells you just need to buy a bigger pump, send them our way and I'll let them know that there's much cheaper, much easier solutions to install and test than that big vacuum pump improvement, which also will lead to higher electricity costs, more heat in the shop. I mean, you guys all have big vacuum pumps, most likely with the machines that you have now, and bigger and stronger isn't always the answer to vacuum pump strength.
Before we wrap up, Mario, there was one thing I want to address I'm seeing a couple other comments, and we'll just take a quick moment. We've got at least a couple left, but Kyle Adams talked about the texture of the material, particularly HDPE. It's got a orange peel-like texture, and how that could compromise the seal when you're vacuum clamping. That's good thinking, right? Because we have to seal, and texture is going to be an issue, or at least the surface area, that substrate that we're milling. We have 3 different thicknesses to our tile gasket: a 1/32, a 1/16, and a 1/8. And those are designed, the thicknesses is based upon the texture or the surface area, any kind of striations that you might have on that surface area that you're milling that might compromise the seal. So the thicker the gasket, hence the 1/8, the more forgiveness that you're going to have to fill in those gaps or those striations. So to answer your question, Kyle, on the chat, that we have people running our tile gasket with like polywood that's very exaggerated in terms of its simulated grain. But we have many customers cutting HDPE like you are, or 3x3 parts, no tabs, single passes, by the way.
And I'll interject here because somehow a question came up on my screen. Brad was asking, how does tile gasket work on nesting routers with auto offload? This question comes up to us from time to time. And again, every shop's unique, every machine is unique, every auto loader is unique. So we've had plenty of customers who tell us their auto loader wasn't causing any problems. We've had some customers who told us that it did cause some problems. In fact, one customer put a little dent in his auto offloader as it went to go push off the parts, and they were still vacuum clamped in place so well because the tile gasket just suction cupped everything in place, and the parts wouldn't move when the auto loader went off. So you may need to do some experimenting. We've had some customers tell us they just wait about 5 to 10 seconds to get that auto loader to start pushing so that a little bit of air can bleed back in and not so suction cupped in place. We also want to make sure that the pressure of that machine, if it goes down too far. So I've seen some auto loaders that are Z'd to the top of the spoil board. And if they don't account for the gasket, they can do some damage to the tile gasket material. So you have to do maybe some experimenting within your shop to know what kind of wear that autoloader will do for the machine. But there's some adjustments that are sometimes needed to do that. But we have plenty of customers around the country that are using autoloaders, offloaders with the tile gasket solution.
Great answers, guys. And I have to go back, Todd, with the vacuum pump size. I think that Mike's mentioning that you don't need to buy a bigger, better pump. Got a lot of praise because that just saved a lot of people a lot of money. A lot of heart emojis and praise emojis. That was pretty fun to see.
Yeah, I think a great deal of our country's GDP has been wasted on buying bigger vacuum pumps. There's seriously over 2.5 decades of doing this. I've heard a lot of angry people talking about, I don't know why that guy talked me into a bigger pump when these solutions are so much easier to install. So take that for what it's worth.
Okay, once again, we will reply to all the questions that we didn't get to during our Q&A here today. Like Mike and Alex have said, we are here to serve our customers via online chat, via email, phone calls. We're always happy to answer all your problems and questions, those only relating to vacuum clamping, not all your problems. But,
let us know what your problems are. Like I say, everybody's unique, but maybe we have a customer that is similar to what you're trying to do, similar to the challenges that you've had, and we've helped address those, and we can send some photos or ideas of something that's going to be helpful for your specific, unique application.
Right.
Brian asked me to share the discount code again. And once again, you guys can go to our store all the way through tomorrow, and then it's time to enjoy the weekend. The code will expire tomorrow at midnight. But it's allstarcnc.com. You can go to our shop now, and then when you're checking out, you put VAC10, capital VAC 10 for the 10% off and your free t-shirt that will send that way.
Is that VAC all capital? Capital V,
Yep.
capital A, capital C, 10.
Correct.
Right. Back 10 is the discount code.
Mhm.
And then one last thing that I would like to end with, we've had a lot of attendees today, and we do appreciate your time. We do hope that this has been helpful and informative and will ultimately result in better production, better profitability, better products, better or happier clients for the work that you're doing. I mentioned earlier how collaborative and how helpful our social community is in CNC routers, and we value that so much. When people provide recommendations or referrals, it's been very powerful for us. And part of that consultative approach that we have, we try to gain clients for life. We sell gaskets, but it's really about the teaching that we provide. So if we've helped you today, if you purchase some of our products, if you've relied on Mike, Daniel, or anybody else in our team here to help you out, pass on the word. We would very much appreciate it. And thanks for attending today.
Thank you, guys.
Thank you.
And we'll look forward to working with you.
Stay tuned for a link. The recording for the presentation will be available. Feel free to pass it on to anybody else. Thank you again. You guys have a great rest of your week and a wonderful weekend coming ahead.